Okay, I want to talk about now functional groups in organic compounds. So a functional group is very important. Usually in an organic molecule, a big portion of the molecule is usually a hydrogen, carbon-carbon single bonds, double bonds, and high carbon hydrogen single bonds. But what makes a organic compound distinct is the functional group that is bonded to. So you can think of the carbon, like you can think of some parts of the molecule as kind of the main framework, and then you have these functional groups in addition to the main portion of the molecule. And it's the functional groups that actually will determine both the physical and chemical properties of the molecule. So we're going to learn about, and then also functional groups help us classify the different types of organic molecules. Okay, and then also I pointed out that the functional groups determine, in most cases, the structural and functional properties of the organic compounds. And it's also, the functional groups have specific names. So you can, from the name, you can easily say what functional group that molecule belongs to, or what functional group it contains. Okay, so let's just go through some of the functional groups here. So the first type of functional group belongs to a class of molecules called alcohols. So an organic compound that contains this, what's called OH group or hydroxyl group, is called an alcohol. And the compound, or the alcohol, the hydroxyl group, it's bonded to a tetrahedral carbon atom. So for example, here's a schematic representation, or a bonding arrangement, a skeletal representation, we'll call it, of an alcohol or a hydroxyl group. So you can have a sp3 hybridized carbon or a tetrahedral carbon with 3 single bonds around the carbon. And this is called an R group, a generic this is called a generic carbon containing, or generic R group. So in some cases, R can just be equal to hydrogen, or it could either be equal to another carbon atom. Okay, so the hydroxyl group, there's a single bond between the oxygen of the hydroxyl group and the main portion, or the rest of the molecule. This hydroxyl oxygen, it's always bonded to a carbon atom in a single bond. So this is just the generic formula for an alcohol. Here's a real example. So you can have a hydroxyl group that's bonded to the framework of a 2-carbon alkane. And the parent alkane for this is ethane. So it's no surprise that this molecule is called ethanol. So here's the Lewis structure for ethanol, and I'm sure it's a molecule that you're very familiar with. So it's used as both as for a beverage, a drinking beverage. I don't know if that's what one would want to call it, spirits or liquor. Let's call it what it is. Here it's also used as a fuel additive, by the way. So here's the condensed structural formula for ethanol. So remember that this hydroxyl group, the oxygens, has two lone pairs. Okay, and then of course here's a ball and stick representation, more of a three-dimensional representation of the ethanol molecule. So just that, to go over this again, the carbon atoms have a tetrahedral geometry. Okay, so this carbon has 4 single bonds, 4 electron groups. So 3 of the single bonds are between the carbon and the hydrogen. The 4th single bond is between carbon and the second carbon. Now the second carbon is also tetrahedral. It has 4 electron groups. 2 of the electron groups are carbon-hydrogen bonds. The 3rd electron group is to the methyl carbon, or the first carbon. And then you have this carbon-oxygen single bond to the functional group. And even the oxygen is tetrahedral. Well, no, it's angular or bent, but it does have a tetrahedral. It has 4 electron groups, 2 lone pairs, and then the 2 single bonds. So it is, the electron group geometry is tetrahedral, in fact, but there's just 2 atoms attached to it via a single bond. So it's a bent or angular geometry. Okay, so that's the first type of functional group. The second type of functional group is called an amine. And an amine it's a compound that contains an amino group. And nitrogen, now you have a nitrogen atom bonded to either 1, 2, or 3 carbon atoms. Okay, so there's 3 different subclassifications of amines. So the amines they're classified as either primary, secondary, or tertiary. This means when you say 1 and then the degree, it means in organic chemistry, you say primary, you say secondary, and tertiary. So we saw how we can classify carbons, primary, secondary, and tertiary carbons in organic compounds. Well, we can also classify amines according to how many carbon atoms or hydrogen atoms are attached to that amine. So the simplest, one of the simplest amines is methylamine. So here's the condensed structural formula. We usually don't write the lone pairs, but remember the nitrogen atom has 1 lone pair. And so you have, this is an example of a primary amine, because in a primary amine, the nitrogen atom on the amine functional group forms a single bond with only 1 carbon atom. So, okay, so that's why it's called a primary amine. All right, so now remember, nitrogen usually has 3, forms up to 3 bonds. Okay, so in this case, in an amine, 2 of these bonds are nitrogen-hydrogen bond, and then the 3rd one is to a carbon. So a primary amine, you have to have 2 hydrogens because you need 3 bonds, and by definition, a primary amine is a molecule that only forms a bond to only 1 carbon. So in primary amines, another clue of a primary amine is you have 2 hydrogens attached to the nitrogen. Now a secondary amine. In a secondary amine, you have 2 carbons, 2 bonds, 2 carbons attached to the nitrogen. So here's an example of a secondary amine, a dimethylamine. Okay, so this is one way. This is these condensed structural formulas, and remember, if you have 2 identical groups, this CH3 group attached to the same atom, you can denote it by this parentheses and then the subscript 2. Okay, so if we look at the ball and stick model, the 3-dimensional model, we see that you have the nitrogen. You have 3 bonds to the nitrogen again. You have 2 nitrogen carbon bonds, 2 nitrogen carbon bonds, and 1 hydrogen. So the hallmark of a secondary amine is number 1, 2 nitrogen-carbon bonds, but in addition, you have one hydrogen-nitrogen bond. So if you have one hydrogen bonded to a nitrogen in an organic compound, a single bond, that's a hallmark for a secondary amine. Moving on to a tertiary amine. Now in a tertiary amine, you have three nitrogen-carbon bonds. So you already have the three groups, the three bonding groups. So you don't need a hydrogen. You don't have a, well, it's not, you don't have a hydrogen attached to covalently bonded to the nitrogen. So you have three identical methyl groups in this triethylamine, and this is an example of a tertiary amine. Now, I want to point out this example, the two groups, the two carbon-containing groups attached to the amine in the secondary amine, those are identical methyl groups. But they don't have to be identical. They could be different. And likewise, the three carbon-containing groups attached to the nitrogen in tertiary amines, they don't necessarily need to be all methyls. One can be an ethyl, one can be an isopropyl, for example. One could be a hexyl. Okay, so it can vary. Okay, so now you have another functional group called a carbonyl group, and you have two subclasses of organic compounds containing a carbonyl group. Now, the hallmark of a carbonyl group is this carbon-oxygen double bond. Okay, so there's two classes of organic compounds containing this carbon-oxygen double bond, and those two classes are aldehydes and ketones. So in aldehyde, you have the carbonyl, you have this carbon, the carbonyl, they call this the carbonyl carbon and the carbonyl oxygen. There's a carbon-oxygen double bond, so the carbon has, it can form, you have to have a total of 4 bonds to a carbon. So 2 of these bonds are in the double bond. And then, so that means you have to have 2 more single bonds. So in an aldehyde, one of the single bonds from the carbonyl carbon is to another carbon atom. And then the second bond to the carbonyl carbon is a hydrogen atom. Okay, and the oxygen, notice the oxygen itself, it has 2 lone pairs, and then it has two bonds, in 2 bonds that make up the double bond. So remember we said that oxygen tends to form two bonds. So you can have these 2 bonds are in the double bond. Okay, so you have, of course, 2 lone pairs. And so you have the 2 lone pairs plus the bonding pair on the oxygen makes a tetrahedral, not a tetrahedral, makes an octet of electrons on the oxygen. Okay, so here's an example of an aldehyde. One of the simplest aldehydes is as acid aldehyde. So in this compound, you have a carbon bonded to another carbon in the methyl group, and then you have a carbon attached single bonded to a hydrogen. So in an aldehyde, one of the carbonyl carbon single bonds is to another carbon, and then the other is to a hydrogen. And then here's the ball and stick representation of an aldehyde. Now, the carbonyl carbon in a aldehyde, or in the carbonyl functional group, the carbonyl carbon is trigonal planar. Okay, because you have 3 electron groups, the double bond, and then the 2 single bonds, the carbon-carbon single bond and the carbon-hydrogen. So this is a trigonal planar geometry. This carbon is sp2 hybridized. This oxygen, of course, only forms 1 bond to the carbon, so it's also part of this plane. And in addition, you have the 2 lone pairs. So you actually do have trigonal planar electron geometry on this carbonyl oxygen. Now the second subclass of or class of organic compounds that contains this carbonyl group is called the ketones, okay? Okay, so the second type of a carbonyl containing functional group we said are called ketones. Now remember, in aldehyde, you have a carbonyl carbon that's bonded to a carbon and a hydrogen, a single bond to another carbon and a single bond to a hydrogen. In a ketone now, instead of having a single bond to a hydrogen, we have a bond to another carbon. So we have two separate carbon-carbon single bonds from the carbonyl oxygen. And so this is an example of a ketone. This is called acetone. So acetone, or the other common name, the acetone's a common name for this ketone, one of the simplest ketones. If the simplest ketone, or when I say simplest, I mean the lowest molecular weight ketone is acetone. But we can also call it propanone. Okay, so it's named after the parent compound, the parent alkane, which contains 3 carbons, and that's propane. Okay, now we have another class of functional groups called carboxylic acids, and the carboxylic acids contain the following functional group. Okay, in the carboxylic, this is called a carboxyl functional group, and it's the whole, the functional group includes the whole shaded region here. So in a carboxyl functional group, you have the rest of the molecule denoted by an R. You have what looks like a carbonyl carbon, but don't think of it as, I wouldn't think of it as a carbonyl group, because then it's easy to mix up an aldehyde ketone and a carboxylic acid or a carboxyl functional group here. So think of this whole unit as a carbon bonded on one side to the rest of the molecule. And by the way, this R group can be a hydrogen. Okay, so you have one compound where that's a hydrogen, and that compound is called formic acid. Okay, now if you have a carbon, of course, you can have what's shown here. If you have a single carbon bonded to the carboxyl group, that's called a acetic acid. Okay, so you're familiar with acetic acid. It's basically vinegar, or vinegar is a dilute solution of acetic acid. So going back to what this functional group is, the carboxyl functional group, so you have a carbonyl-like group here, a carbon double bonded to an oxygen atom. But now, in addition to the single bond with the R group, this carbon atom is now bonded in a single bond to an oxygen atom. Okay, and remember, this oxygen atom has 2 lone pairs, which is bonded to a hydrogen atom. So you can kind of think as a carboxyl functional group as maybe a carbonyl group combined with an alcohol, but I wouldn't think of it like that way. Try to memorize or try to understand that the carboxyl group is this whole group right here. Okay, so this concludes our survey of functional groups. So thank you very much.